So here we go. Let's look at our first one. We're going to do this on paper instead of on the screen they give us. So let me take 1 second to write this down so I know which pieces we're using. Again, if you write down one sign, one number, anything wrong, then it's going to cause you to get the whole problem wrong. So be very, 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 very focused. Okay. So here we go. So we have our matrix. So it's negative 10x minus 3y equals negative 1. 4x plus y equals 1. This is a system of equations, which means that whatever x is in one, it'll be the same in the other. So we're going to use an augmented matrix to be able to solve it. So the first thing I want to do is I want to write my matrix, my augmented matrix. Again, all that means is just put in the numbers without the letters. Okay? Now this one is a 2 by 3, so we only have 2 variables, 2 equations. So 2 equations and 2 variables. So it's going to be a little simpler than a 3 by 3 in that there aren't as many row operations, but they work in exactly the same way. So we've got row 1 and row 2, right? So remember, our first thing we're going to do is we're going to be using row 1 to eliminate right there, that 4. Okay? Now, in an ideal world, that negative 10 would have been a 1. But guess what? The real world is not an ideal world, so it's just not going to happen always. So, what we're going to do is we're going to take row 1 plus row 2, and that's going to give us what we're going to call new row 2. Okay? And remember again, remember what you're trying to eliminate. We're using these numbers right here. These are the things that I want to have as opposites. So right now I have 10, negative 10 and positive 4. I can't turn a negative 10, so the opposite of 4 is negative 4, right? I can't turn a negative 10 into a negative 4. I also can't turn a 4 into a negative 10. But I could turn them both into a negative 40. So think like LCD, right? What is something that they'll both divide into? Now negative 40 is even bigger than I need. I could also use negative 20. I could turn a 4 and a 10 into a 20. It really doesn't matter. If you just multiply them together, as long as you got, remember this one's positive, so what I want to do is I want to turn it into, I want something negative to get rid of it, right? So this means that I'm going to have to multiply not only row 1 by something, but also row 2 by something, okay? So let's do our row operations, okay? Remembering that I'm going to get a new matrix when I do this, right? And when I get that new matrix, whatever row I'm using, whoops, eraser there. Whatever row I'm using won't change. So I'm still going to get row 1, but I'm going to get new row 2. So row 1, once I'm done, is going to be exactly the same as what it was when I started. Okay? That's the one I'm using. But row 2 is going to be new row 2. So I'm going to be, and it's going to have a 0 right there. That's the goal. Okay? So that's again why I'm using these two. So negative 10 and 4. Can't turn a 4 into a negative 10. Can't turn a negative 10 into a 4, but I could use negative 40 to get them to be able to subtract away, right? So that means that if I'm going to do that, it's negative 10, negative 3, negative 1. That's row 1, right? Row 2 is 4, 1, and 1. And I want opposites right here. They're not opposites now, but they do have opposite signs. So at least I know I don't have to mess with the signs. I just have to mess with the numbers. So what I'll do is I'll multiply the top row by 4 and the bottom row by 10. Now again, some of you are sophisticated enough to know that I could have used 20 as the number, which means I'd multiply the top by 2 and the bottom by 5. But it doesn't matter how big these numbers get. They'll all divide out in a minute anyway. Okay? So here we go. Once you do that, I get negative 40, I get negative 12, and I get negative 4. In the bottom, multiplying everything by 10 gives me 40, 10, and 10. And now what I'm going to do is I'm going to take those two things and add them together. Well, negative 40 plus 40 gives me 0. That's the whole point, right? Negative 12 plus 10 is negative 2. And negative 4 plus 10 is positive 6. And this thing is my new row 2. So it goes into my new matrix right there. Okay? Now, hopefully you're happy with that. If you're not that worried, because you're going to see it over and over and over again. Let's see. I don't know. No, I can't just get more page by scrolling up. Doggone it. But, okay, so we have our new matrix there. Okay. So this is what our new matrix looks like. This one right here. Right? Okay, don't like those circles. Let's try just circling it. So this is our new matrix. We started off with our original matrix. Now we have our new matrix, and it has a row 1 and it has a new row 2. So now what I need is a new row 1, because what I need to do is I need to get a 0 right there, right? Since that's the second column, that means I'll be using this second row, or new row 2, to get it, right? Second column, working in the second column means you're going to be using the second row. All right. So I need to eliminate right here. Okay? So what I'm going to do is I'm going to rewrite it on another page so that I can keep it organized. Now you rewrite these notes on paper as I go. You should be writing them, not just following along with me. So you could have it on a piece of paper where it's just going down, 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 down. Okay? Right? Notice how I wrote the original matrix here and what it became right beside it. Again, that's a very great organizational tool. Keep yourself organized, and you can do a million of these. I took a whole class in these. Tell me how fun that was. Alright, so here we go. So remember, we still have row 1, and now we have our new row 2. And it's negative 10, negative 3, negative 1, 0, negative 2, 6. Okay? Now we're going to build a new matrix, right? Because I'm not done with these things. I'm still going to have new row 2. It's not going to change. That's the one I'm using, right? Because remember, I'm going to use this row to eliminate right there. Okay, so I'm trying to get rid of that negative 3. So I need to turn that negative 3 into a 0. So the numbers I'm using are negative 3 and negative 2. Well, negative 3 and negative 2 are not opposites. The opposite of negative 3 is positive 3. I can't turn a 2 into a 3. Now, I could, uses a bunch of fractions, don't want that. So instead, what I can do is, I know I can turn a 2 and a 3 into a 6, right? But I need one of them to be negative and the other to be positive. Well, it doesn't really matter which one you make which, but since the bottom only has a 0, has 2 numbers, I'm going to use the positives. I'm going to change the signs in the bottom. So all I need to do to get this negative 3 to turn into a negative 6 is to multiply it by 2. But at the bottom, I need to multiply by negative 3, because not only do I need to change the number, I also need to change the signs, right? Now those are now opposites. So I'm all good with opposites. So let's do our operations. Row 1 is negative 10, negative 3, negative 1, and I'm going to multiply that entire thing by 2. New row 2 is negative 2, sorry, I'm lying, 0, negative 2, and 6. And I'm going to multiply that entire thing by negative 3. Again, remember a negative because I need to change not only the number but also the sign. Multiplying that out gives me negative 20, negative 6, negative 2. All I'm doing is distributing, right? It has to be multiplied times, whatever I choose to multiply by has to be multiplied times the whole row. Negative 3 times 0 is still 0, so see, it doesn't change that part. It gives me a 6. Negative 3 times that gives me negative 18. And now I'm just going to add those two together, right? And that's going to give me my new row 1. Right? I had row 1, now I'm changing it, so it's going to be new row 1. So that gives me negative 20. 6 minus 6 is 0. Negative 2 and negative 18 is negative 20. So my new row 1 is negative 20, 0, and negative 20. Oops, I'm sorry, I forgot to put that in there. Now do you notice I have numbers on the diagonal, and I have 0 here and 0 there. And that's what I'm looking for. Now, 2 by 2 equations don't have row 3, so I'm not going to do new row 3, final row 3, final all that blah, blah, blah. Because it was only a 2 by 3 system, they only had 2 rows, then I only had to do it twice. Do you see that the smaller the system, the smaller the amount of things that you have to do. Now let me show you how easy it is to solve this because we have it in this format. Now I'm going to show you how to get those ones there. I hate it because you don't need them. And then I'm going to show you why you don't need them. Because all you really need to do is just solve those new rows. So you have new row 1, we have new row 2, we have negative 20, 0, negative 20, we have 0, negative 2, 6. So what this is really telling me is that 20x's equals negative 20, or negative 20x's, and negative 2y's equals 6. So I have negative 20x equals negative 20 from new row 1, and from new row 2 I have negative 2y equals 6. And those are just two simple linear equations, which you solve by doing the opposite. The opposite of multiply by negative 20 is divide by negative 20. So divide both sides by negative 20 gives me x equals 1. The opposite of multiply by negative 2 is divide by negative 2. So negative and the 2 divide away. That gives me y equals negative 3. Notice that my x and my y are by itself. So I just write the answer in the form of an ordered pair. And I'm done. So there's your answer. Negative, positive 1, 3. Alright? So you only use the number of row operations you need to be able to get this diagonal of numbers and zeros everywhere else. So we didn't have to use all those fractions that they show you how to use. Alright? And we're going to do some more of these. I think you should do as many as you can of practicing this because this is going to be on the test, it's going to be on the final. So make sure that you really understand what's happening here as we go. So let's go back and type in that answer just to make sure that I have it right. So the solution set is, remember, it's an ordered pair, so it's got to be enclosed in parentheses. And what did we get? We got 1, comma, negative 3. Really got to learn how to write things down, huh? Okay? And we'll check our answer. There we go. Now, notice there were 2 other solutions that could have happened to you. It says the system has infinitely many solutions. And Again, I don't know if that's going to happen or not, so I'm not going to mess with it. If you get two numbers, then you have a solution, type it in. Okay? So what I'm going to do is, this is the only one of these, so I'm going to go back to this. Let's go back to number 12. Okay? And I'm going to show completed work, so we know what the answer is going to be. And I'm just going to hit similar question. And you see it gives us one where the solution's set, so you're going to get an answer. You don't get this. You don't get the funny answer. Okay, let's see. Let's do similar question again. To see, it's giving you that, so you don't get the funny answers. Okay, we'll try one more. Similar question gave us an answer. So it's never going to be infinitely many or empty set. There's just a little help from your teacher. Okay? Don't say I never did anything for you. All right, let's look at number 13. Now, it says use it to solve the system of equations. If it has infinitely many solutions, give the solution with y arbitrary. Again, I don't think that's going to happen to you, but you know what that means. That doesn't mean I know everything, but we will check it. I'll check it for you. I'll do exactly what I just did. We went through 4 of those, and it didn't. So if it didn't there, then it most likely is not going to do it when you're doing your homework. Okay, right now, hold on, give me a second. I'm just writing out the system of equations so that I can get a blank piece of paper and do these on. Okay, all right, here we go. So I have my system written down. Let me go back because I wrote a sign wrong on one of them. So I'm going to be very careful about that. Okay, so here we go. So we have your system there, and I'm not going to worry about the original. I'm just going to rewrite it as an augmented matrix. Okay, so it was x plus y minus 2x equals 15. So that's 1, 1, negative 2, negative 15. Second one was 2x's minus a y plus a 4 is 48. Don't worry about the numbers getting bigger because they're going to divide out. You get 1, negative 2, positive 2 at z's, and that equals negative 9. That's our equal symbol, and there we go. Okay? Now, first thing, name the rows. Row 1, row 2, row 3. If you don't name them, I have no hope for you. Okay? Remember our first row operation, because we're going to get a new matrix, right? We're going to get several new matrices here. But the first one, we're using row 1 to eliminating column 1, right? So we're going to be using row 1, and we're going to be eliminating these two numbers here. This time we have more because we have 3 rows, right? Last time we only had 2 rows. Well, if we're using row 1, then that means that in our new matrix, row 1 will stay the same. Whatever row you're using to eliminate with stays the same in the end. Okay? All right. So let's start. So we're going to take row 1 plus row 2. Remember, that's going to give us new row 2. Right? So we're going to have new row 2, and we're also going to get a new row 3 in a minute too. Okay? Well, right now, here's what we're taking. Is we're using row 1, so these two numbers, these positions, so 1 and 2. So I have 1 and 2, and I've got to turn those into opposites. Well, the opposite of positive 2 is negative 2. So what I need to do is I need to turn that positive 1 into a negative 2. Well, the way to turn it into a negative 2 is simply multiply it by negative 2. And that's why 1 is such a good number to have. Yeah, and again, you can rearrange these in any order you want to make, if you think it makes them easier. So we're going to multiply row 1 by negative 2. Do you see the logic there? So you need opposites, and the opposite of 2 is negative 2. So and you can turn it 1. So row 1, row 1 is 1, 1, negative 2, negative 15. Row 2 is 2, negative 1, 4, 48. Okay. And we're going to multiply the entire top row by negative 2. So that gives us negative 2, negative 2, positive 4, positive 30. The bottom, we're not multiplying by anything this time because we didn't have to. Notice that these two are opposites, and that was the whole point, because now when I add them together, I get my 0 that I need. But remember, I can't just add those together. I have to add everything together. And again, these numbers are getting bigger. Don't worry about it. I don't care. You don't care. They will get smaller as you go. Okay? And that thing is our new row 2. Pretty darn easy once you get the pattern down. Now, I'm going to erase this because I need to do the same thing because I'm still using row 1. Notice I didn't erase that. But this time, I'm working on row 3 to get a new row 3. So row 3 is 1, negative 2, 2, negative 9. So here's what I'm trying to eliminate. Now I have 1 and 1, but 1 and 1 aren't opposites. But the only thing I need to do to get opposites is change the sign of one of them. And it doesn't matter, you can change it in the top or the bottom, makes no difference. I typically change the top, I don't know why. Again, it makes no difference whatsoever. Okay, so let's get rid of this multiplication over here. We're going to be doing new ones. So all I'm going to do is change the signs in row 1. But if I change one sign, that means I have to change them all. So it becomes negative 1, positive 2, positive 15. Row 3 is going to stay the same, right? Because I wanted a negative 1 in the top and a positive 1 in the bottom. So negative 2, 2, negative 9. Okay. Now that I have opposites right here, which is what I wanted, right? I need to add them together. That gives me the 0 I need, negative 3, 4, and 15 minus 9, what is that, 6? Me and my math. And remember, this thing is our new row 3. So it's going to go right here. How easy is that? Okay. Now, I have a new matrix, right? This is my new matrix here. But it doesn't have all the zeros that I need yet. So it's not finished. So I'm going to have to do some more row operations. So give me a second to write down that new matrix. And then we'll go through the operations for that one. Okay, so let's go to a new page. So here's my new matrix. Now, if you're doing it on a piece of paper, you can just go down, down, down. Mine just doesn't work that way. So what I have, remember, oops, back to black, is row 1. I have not row 2, but new row 2. And I have a new row 3. All right? Row 1 was the one we used, and it never changed. We used it, but we didn't change it. But we did change the others. Now remember, to get this new matrix, we're working with row 2 and column 2, right? So I'm using this row to eliminate this 1 and this negative 3. Well, the row you're using doesn't change. So new row 2 is going to stay 0, negative 3, 8, and 78 in your matrix. Now down here, we're going to multiply with it and change it all over the place. But when we're working on, when we're talking about the matrix, we're not going to change it. Now we're going to get a new row 1, and we're going to get our final row 3, right? Row 3 is changed once already from new. Now it's going to change to final. Final is good. Remember, final means you're done with it, right? Okay, here we go. So, excuse me. So here we go. We're doing our row operations. So we're using new row 2 plus row 1 to get new row 1, right? So new row 2 is 0, -3, 8, and 78. Row 1 is 1, 1, -2, -15. Now we're not eliminating in the first position. Remember, we're using row 2, right? So this is the one I'm trying to eliminate here. So that's where I need my opposites. Well, I've got a negative and a positive, so I've already got good signs, right? They have opposite signs. I just need to see if I can turn one of these into the other. And I can turn a 1 into a 3 really easily by simply multiplying this whole equation by 3. Okay? So the top one, in this case, is not going to change. We're multiplying the entire bottom one, though, by 3. That give me 45. -45. Okay? Let's see. 3 times 1 is 3. 3 times 1 is 3. 3 times -2 is -6. 3 times -15, -45. And you notice that in this second position, I have opposites now, which is exactly what I needed. So let's add them together. 0 and 3 make 3. 3 minus 3 makes 0. 8 minus 6 makes 2. 78 minus 45 gives me 33. And this thing is my new row 1. So we'll put it in position. 3, 0, 2, 33. Okay? So again, make sure that you draw out, see what I did up here in this red? Draw out what you're using and what you're trying to get rid of, and then that way it'll keep you organized. Okay? Now, I'm going to erase the math that I did here, because now we have to do the same thing with row 3, which is actually new row 3, right? So we're still using, shouldn't have erased all that since I'm still using some of it, but that's okay. New row 2 plus new row 3, and we're going to get our final row 3. Okay? Well, new row 2, we know what that is. It's right there, right? New row 2. 0, -3, 8, and 78. New row 3, it's this thing. So that's 0, -3, 4, and 6. We're trying to eliminate in this second column, right? Row 2, second column. So make sure you keep those things in mind. If you're using row 2, that means you're trying to eliminate in the second column. And notice that 3 and -3 are the same number. So I don't have to do anything to the number. All I need to do is change the signs. And I can change the signs in the top or the bottom. I'm going to change the signs in the bottom this time because that 78 is so big. And so that means it's going to keep it positive. It wouldn't make one bit of difference no matter what you do. You could change the signs in the top or the signs in the bottom. It makes no difference. And since all I had to do was change the signs, I'm going to go ahead and just do the addition here. Okay? And this thing is my final row 3. So that gives me 0, gives me 0, gives me 4, and it gives me 72. Okay? Now the last thing is I want to get those last two final rows, final row 1 and final row 2. So I need to write another matrix. So take the matrix that you have, the 3, 0, 2, 33, 0, -3, 8, 78, 0, 0, 4, 72. Okay, we're going to take that and use that as our new matrix. So we have a new row 1, we have a new row 2, and we have our final row 3. All I'm doing again is rewriting that from the other page. 0, negative 3, 8, 78, 0, 0, 4, 72. Okay. Now, if we were using substitution, we could solve this one right now. But we're not. We're using Gauss-Jordan elimination. So you keep on going and doing it right. I don't care what you see on the internet. Do it right. Right? We're going to get our last one. So it's final row 1, final row 2, and of course we already have final row 3. That's the matrix that we're building now. So it's final everything. So after that we can solve the equations. Remember, we're in our third matrix. So we're using row 3, and we're using it to eliminate right there in the third position, right? Third matrix, third row, third column. Keep organized. Okay, now, so we're going to use first final row 3 plus new row 1 to get our final row 1. So let's write down what we have. So final row 3 is 0, 0, 4, and 72. New row 1 is 3, 0, 2, and 33. And we're trying to eliminate right there. Now, I can turn a 2 into a 4. Easy. But notice that they're both positive. And for opposites, I need to not only have the same, I want the same number but different signs. So what I'm going to do is, I'm going to turn this positive 2 into a negative 4. Okay? Alright, which means I'm not going to be multiplying the top one by anything. But I'm going to be multiplying the entire bottom row by negative 2. See it? Negative 2 times 3 is negative 6. Negative 2 times 0 is 0. Negative 2 times negative 2 is negative 4. Negative 2 times 33 is negative 66. Again, it doesn't matter which thing you change into opposites. You could also just take 4 times 2 and get 8 and change the signs of all of them. Whatever number you want to use as opposites is up to you, but bigger numbers, bigger numbers. Alright, now let's add them together. 0 and negative 6 gives us negative 6. 0 and 0 gives us 0. 4 minus 4 is 0. And 72 minus 66 gives us 6. And this thing is our final row 1. Oops, sorry. Remember, since we're using final row 3 as our eliminator, it stays the same. So now we'll stick in our final row 1. Alright? Now we need to do the same thing to get final row 2. Let's erase this math that I did down here just to get us some room to work. Notice that I kept final row 3 just as it is because I'm still going to use, that's the one I'm using. But what I'm going to be using now here is new row 2 to get final row 2. So it's 0, negative 3, 8, and 78. I'm trying to eliminate these two. Well, I can turn a 4 into an 8 easily, right? But I also, not only do I have to change the number, I need to also change the sign. So you could just go through and change the signs and then multiply by 2, or you can multiply by a negative number. Your choice. I don't care. Now, so because what I need is to turn this 4 into a negative 8, which means I'm going to multiply the whole top by negative 2. Okay, which gives me 0, 0. Negative 2 times 4 is negative 8, which is the whole point. Negative 2 times 72 is negative 144. Doesn't matter that the numbers get big, they'll get smaller soon. 0, negative 3, 8, 78. Okay? Now, let's combine them. 0 and 0 still make 0. 0 minus 3 is negative 3. 8 minus 8 is 0. Negative 144 plus 78 is some number that I'm going to use a calculator for because I can't add, subtract, multiply, or divide. I could, but I don't want to. It's negative 66. And this thing is my final row 2, which I just need to stick up here in my final matrix. Okay? Now, notice it's final everything, right? That means that I'm done with the matrix operations. And I could, and remember I also know that's the case because I have a diagonal of numbers and then some triangles of zeros. So that's how I know that I'm done. I could turn all of those into ones. I could divide the top by negative 6. I could divide the middle by negative 3 and the other one by 4. That would turn all of those into the ones. Well, doing that is the same thing as solving the equation. Okay, so let me show you what I mean by that. Oops. So let me get rid of the row operations that we used down here. And I'm going to just rewrite them as simple linear equations. So the top one is negative 6x equals 6. Because everything else was zeros, who cares, right? Then we have the next one, negative 3y equals negative 66. And on the bottom, 4z equals 72. And notice all I have to do is solve by dividing by the coefficient of each one. That divides away, gives me x equals 1. That's a negative 1, sorry. Divide that by negative 3. Those will divide away, gives me y equals, what is that, 22? And yes, I'm using a calculator to make sure I get the right one. So we'll divide the last thing by 4, gives me z equals 18. So it's negative 1, comma, 22, comma, 18 as my answer. Keep it very visual and keep the idea of opposites, and you cannot go wrong. Unless you make simple errors, simple arithmetic errors, which is very easy to do. So use that calculator as much as you need to. So let's type that in just to make sure, because you know how I am. Ah, well, I don't have to because I left the answer on. So it's negative 1, 22, 18, which is exactly what we got. Sadly, I think these are hilariously fun. You will not, but you got to do them anyway. Now, let's click on this. I do not think that we're going to get anything but, yeah, so this one has a unique solution. So don't worry about infinitely many or inconsistent. It's just going to keep on giving you ones where you get numbers. You see it every time? So you're never going to use B and C. It's always going to be A, and you're going to type in your 3 numbers. Okay? So that means be very careful with them. All right. Let's go to the next question. Last one. Here's our system. Let's click off the answers so that we don't have to worry about having that in our way. And let me write down the original system. Sorry, this takes me a little while, but if I go to the paper, it won't let me see the original problem. So you need to be writing it down on paper anyway. Cannot tell you that if you just follow along the notes, you're not learning. You've got to write it and do it if you want to learn anything. Okay, here we go. Oops, that's not what I wanted to do. Piece of paper. There we go. All right, so here we go. Our system was x plus y. So we had 1x, so remember row 1, 1x, 1y, negative 5z's, and that equaled negative 29. Row 2 is, well, there were 3 x's, negative 3 y's, 2 z's, and that equaled 16. And row 3, there was 1x, 3 y's, negative 4 z's, and that equaled negative 30. All right? Now, you could rearrange those in any way you want to. I'm going to leave them just the way they are. I don't care. If you look at this one, it's very similar to the last one. What they did was they just hit similar exercise. So the process is going to be the same, just different numbers. Now remember, that first we're going to get a new matrix, right? That's the whole point, is we're building new matrices. And since we're doing the first row, right, it's not going to change. And if we're using the first row, that means we're eliminating in the first column. First matrix, first row, first column. Yeah? And since we're using the first row, it doesn't change. Just bring it on over here, completely unchanged. All right. Now, we're going to use row 1 plus row 2, and that's going to give us our first new row, which is new row 2. So let's write those down. It's 1, 1, negative 5, negative 29. It's 3, negative 3, 2, 16. And again, remember, I'm working on eliminating right there. Anytime I'm using row 1, I'm trying to eliminate in the first row, in the first column. Column 1, row 1, column 1. Now they're not opposites, but I can easily turn a 1 into a 3 by multiplying it by 3. But you'll also notice that the signs are not what I want. So what I need to do is multiply the whole top by negative 3. Okay? Because that will give me the opposite of 3. Negative 3 times 1 is negative 3. Negative 3 times 1 is negative 3. Negative 3 times negative 5 is 15. Negative, sorry. Yes, the numbers sometimes get big. Negative 3 times negative 29 is going to give us a positive 87. But you saw a while ago, they divide down a little bit. Now this one we didn't need to change at all, so it just comes over as exactly the same numbers. Notice that I have opposites in the first position now, so all I have to do is add them together. 0, negative 6, 17, and 103. Numbers can get big. You don't care. 0, negative 6, 17, 103. They tend to get smaller as you go. All right? Now, there's our new row 2. Now we're going to do the same thing. Notice I'm just going to leave row 1 up there. Right? I'm going to get rid of all of this, though, all the math that I did. And we are working to get we're using row 3 to get a new row 3. Right? So new row 3 is what we're working on. So, row 3 is 1, 3, negative 4, negative 30. Again, we're using row 1, so that means column 1. And 1 and 1 are not opposites, but they would be if we just changed the signs. So what I'm going to do is I'm going to change the signs on everything in the bottom. Now I just chose the bottom because that's bigger than that. It doesn't make the slightest bit of difference as long as you're careful with your signs, right? So let's just change the signs of everything in the bottom. That becomes negative, whoops, let me use black. Becomes negative 1, negative 3, positive 4, positive 30. And since I didn't do much math, I'm just going to go ahead and do it right there. 1 minus 1 makes 0. 1 minus 3 is negative 2. Negative 5 plus 4 is negative 1. Negative 29 plus 30 is 1. And that is my new row 3. Okay, so now I have my new matrix. Give me a second to write that down so that I can change pages. Again, you'll be on just writing it straight down, staying all organized, keeping everything on one page, so you won't have to rewrite it that frequently. Right? Don't want to keep on doing it. Now, that was our first new matrix. So we were using, right? So if this was the first new matrix, we were using row 1 and column 1. Now, that was our first matrix. This one's our second one, right? This is matrix 2. So, if it's matrix 2, we're going to be using row 2, and we're going to be eliminating in column 2. Right? Make sense? So let's go back and rewrite it. Okay, so it's 1, 1, negative 5, negative 29, 0, negative 6, 17, 103, 0, negative 2, negative 1, 1. Okay, let's put in our labels because that's crucial. This is still row 1, but this is new row 2 and new row 3. Now remember, this is our second matrix, right? So we're using second row, second column. Alright? Well, since I'm using the second row, new row 2 is not going to change. But I'm going to get a new row 1, and I'm going to get a final row 3. And that's what's going to be in our next matrix. Okay? So we're going to use new row 2 and row 1. So 0, negative 6, 17, 103. Circle them in a different color, hopefully. That'll make sure you really know what you're using. 1, 1, negative 5, negative 29. Okay. Remember, we're trying to eliminate here. So I need the opposite of negative 6, which is positive 6. Well, that's easy. I can multiply this bottom thing by positive 6, and that'll get me what I need. So 0, negative 6, 17, 103 won't change. That's nice because 103 is a big number. It's going to get smaller in a second. 6 times 6, I'm sorry, 6 times 1 is 6. 6 times 1 is 6. 6 times negative 5 is negative 30. And 6 times negative 29 is negative 174. Now we have our opposites here, right? So let's add them together. This gives us 6, 0, 30 minus 17 gives us negative 13. And negative 174 and 103, my handwriting is going to be is negative 71. Okay, now this is my new row 1, right? Since we're using row 2, it doesn't change. But now I have a new row 1. And I really hope I did the arithmetic right. We'll find out soon enough, let me tell you. Okay, now, done that one. Now we're still going to use new row 2. But this time we're going to use it with new row 3 to get our final row 3. Okay. So new row 3, which is 0, negative 2, negative 1, 1. We're still, remember this second matrix, second row, so we're working in the second column. I can turn a 2 into a 6, but I also have to change the signs, right? And so that means I'm just gonna multiply this bottom one by -3, because that'll turn this into a +6, okay? So the top row will not change. 0, -6, 17, 103. In the bottom, -3 times 0 is 0. -3 times -2 is 6. -3 times -1 is 3. -3 times 1 is -3. And when we get those combined, it's going to give us our final row 3. 0 and 0 makes 0. 6 minus 6 makes 0. 17 and 3 make 20. 103 minus 3 is 100. So we'll get pretty good with that arithmetic. Let's put that into its position in our latest matrix. Okay? All right. Now, so that was matrix 2 we just finished. So we're going to now be building matrix 3. Well, for building matrix 3, we're going to be using row 3, column 3. Right? So let me write those down for you so that I can go to a new page. 6, 0, -13, -71. 0, -6, 17, 103. 0, 0, 20, 100. So I'll write that down really quickly. So it's new row 1. Oops, like black. New row 1 is 6, 0, -13, -71. New row 2 is 0, -6, 17, 103. And remember, we just got final row 3, so that's what we're working with this time. And that is 0, 0, 20, and 100. So now what we have to do is get our final row 1, final row 2, and we already have final row 3. Third matrix. So we're using third and third. Third row, third column. Which means that our row 3 is not going to change. We're just going to bring it straight over. Now we're going to use it. So it's final row 3 and new row 1, right? And that's going to give us final row 1. So let's put in our final row 3. 0, 0, 20, 100. New row 1, 6, 0, -13, -71. We're eliminating here. Looks pretty ugly, and it is. But at least we have one of them positive, one of them negative. So we don't have to worry about our signs. We just have to come up with a number. Well, the easiest way is simply to multiply the top one by 13 and the bottom by 20. Right? You know that it'll make them the same number if you multiply them by each other. So 13 times 0 is 0. 13 times 0 is 0. 13 times 20. And yes, I know I should know that. Is 260, and 13 times 100 is 1300. Do not panic. You'll get over it. Now let's do the bottom. 20 times 6 is 120. 20 times 0 is 0. 20 times -13 is -260. Better be. That's the whole point. And 20 times -71 is -1420. Now let's combine all that stuff. 0 and 120 make 120. 0 and 0 make 0. 260 minus 260 makes 0. And -1420 plus 1300 makes -120. And this thing is our final row 1. So 120, 0, 0, -120. Okay? Now we'll do the same thing but we're trying to get final row 2. We're still going to go back to our original final row 3 to get it. But I'll erase all the arithmetic from everywhere else. There we go. So new row 2, which is 0, -6, 17, 103. Here are the numbers we're trying to eliminate. Now, right off the bat, you see that they're both positive. So we're going to have to use one of them negative to get the right signs. And the easiest thing to do is take 20 and 17 and multiply them together. So I'm going to multiply the top by -17. Let me put that in red just so that you can see it a little easier. So that by -17, which means the bottom by +20. Because I don't want to change the signs in the bottom, but I do want to change the signs in the top, because I need one of them to be positive, one of them to be negative, right? So let's do that multiplication. My calculator handy. All right, 17 times 0 is 0. 17 times 0 is 0. -17 times 20 is -340. Okay. -17 times 100 is -1700. Hate it. Deal with it. Okay. Now, 20 times 0 is 0. 20 times -6 is -120. 20 times 17 is +340. And 20 times 103 is 2060. Now all we have to do is add those together to get our final row 2. 0 and 0 make 0. We get -120. Get another 0. And 2060 minus 1700 is 360. So that gives us 0, -120, 0, and 360. All right. And that is our final matrix. So we don't have any more matrix operations to do, right? We're in final everything. So final everything means that now we've got it in a position where we can solve it. And again, we know that because we have a series of numbers, right, on the diagonal. Everything else over here are zeros. And we have our numbers 3 equal. Now, remember, these are your x's, these are your y's, these are your z's. So let's just put them in and solve the equations. So it's 20 x's equals -120. It's -120 y's equals 360. And it's 20 z's equals 100. Solve the first one by divide by 20, which gives you x equals -6. Solve the next one by dividing by -120, which gives me y equals -3. I'm really asking these questions like you all are sitting in the class and you could help me. Oh well, I need a classroom. And you get z equals 5. Okay? So put them in the form of an ordered triple. In other words, in a parentheses separated by commas. Let's see if we got that right. Let me write them down. -6, -3, -5. And if I didn't make an arithmetic error, those should be the answers. And you probably already know if I did or not. So let's. So -6, -3, -5. My answer for y is correct. However, your x and z are incorrect, which means I've made sign errors or some issue with them. And of course, you know, I'm doing it on the screen, so it's not going to help. But so I can't find those errors. So I just did a similar one. But you see it comes out with those numbers. I know that I made some kind of sign error or some kind of arithmetic error while I was working with those, which is the most common mistake. And if you think I'm redoing that entire problem because I did, you're crazy. But notice that answer was A, and you put in your three numbers. You'll put in the right three numbers, and B and C are never used, so don't worry about them. And if they're not used here, they won't be used on a test either. Okay? That concludes the last lecture. So we're going to talk about the final exam. I'm going to send you out a review for it. I'm going to just send that on email, just a list of all the topics that you have to work with. And you just go from the chapters, look at those problems from the tests. You can review your old tests and look at those problems and make sure that you can work them. Focus it. You don't have to use every single problem from every single test. Okay? Thanks so much. Sorry I screwed up the last one. Get used to it. Math teachers aren't perfect either. Thanks.